Hello, my name is Pelachaud. I'm going to present work we've been conducting in the CNRS lab Easier Sorbonne University on modeling socially interactive agents that are capable of interacting with human participants. So interactions, our aim is to build socially interactive agents able to manage the impression it gives on users, but also to optimize engagement, for example, to provide the information it aims to convey to users, while also managing interpersonal relationships. So for that, we like to enhance the user's perception of those agents. And in this talk, I'm going to present, to focus on adaptation mechanisms that our work we've been conducting lately. Adaptation during an interaction occurs for several communicative functions, such as favoring engagement, enhancing user experience, increasing rapport, establishing trust, and things like that. So it has quite a lot of function, and it can be signaled through a variety of mechanisms, such as imitation of behaviors, the production of back channels, different forms of alignments, and also temporal alignment, temporal synchronization. Okay? So in our work, we had some research questions we'd like to answer. One is how an agent able to perceive user state and to adapt to her state affect users' perceptions. Another question is how does it impact the user's perception of her interaction with the agent? To answer those research questions, we're conducting studies where an agent is able to adapt to the users in order to enhance engagement or the impression it gives on the users. For that, we're conducting 4 studies, and I'm going to present those 4 different studies. One of the first studies was the adaptation of behavior expressive movement. This work was conducting in a project some time ago. It was a FET Open e-learn. And in this project, we look at one particular signals, social signals, laughter. As we all know, laughter is an essential social signal in human-human communication. And it's a social vocalization that is universal across culture and languages. And it can convey many different functions, such like providing humorous feedback to hilarious stimuli or to praise statement, but it can also be used to mask embarrassment, reinforce bondings. It's in multi-party interaction. It's a very strong social indicators of in-group belongings. As well, it can also be used to elicit interlocutor laughter, and also it can modulate what somebody is saying. So let me show you a short video of hilarious laughter. So what we can see here is that we see the people that are really in lively interaction, and it was somebody said a joke and they're really participating to the laughter. Okay. So in our study, in these first studies we've been conducting on adaptation, we wanted to study the impact of laughter on human experience during a human-agent interaction. Since at the time it was really very difficult to use laughter, to predict laughter during a dialogue, a natural language dialogues, we decided to use another type of interaction that I'm going to introduce in 2 minutes. This work was based on 2 findings that we found previously and by other colleagues, is that the effect of dynamic coupling, that means the interactive loop you can find between participants of an interaction enhances the sense of engagement. And also work by Ginevra and her group found that behavior expressivity is also conveying affective content. So for this study, we rely on the copying paradigms. That is that we aim to copy the behavior expressivity dynamically as it evolved in human performance. So that means that we extract the behavior expressivity of a humans, and on the fly, frame by frames, we copy it on the virtual agent. So the aim of this first study was to how a virtual agent able to copy and to adapt its laughing and expressive behavior on the fly dynamically participates in enhancing user experience in the interaction. As I said, we didn't use natural, but we used music that was triggering laughters. Okay, and you can see here a stimuli of participants that is laughing at the music with the agent. And the agent behavior is not a pure imitation, it's adapting on the fly the quality, the behavior expressivity of the humans. Okay? It's not really, the agent has its own laughter behavior, and it's adapting its behavior expressivity here, the quantity of movements and the speed to the agent, to the human's behaviors. Okay? This study shows quite a lot of enhancement, in particular on the quality of the interaction. So that was the first adaptation studies we've been conducting. Lately, we decided to work again on adaptation, but this time with dialogue, okay, where a humans that is in interaction through natural language with an agent. So that's for that we built an architecture where we have humans analysis that is being detected through a webcam, a microphone, and a Kinect, and the movement that are extracted, the signals extracted and interpreted are sent to the dialogue models that triggers what the agent should say next. And after we have our greater agent platforms that will compute how the instantiation of those intentions into multimodal behaviors. And we have adaptation mechanism here. So in this such a settings, we consider 3 different types of adaptation mechanisms. Each of those adaptation mechanisms that we considered relied on the same scenario, where the agent was acting as a virtual guide for an exhibit on video games in a museum of science and industry of Paris. This is the largest museum of science and industry in Paris. Each participants were museum visitors. We had like almost 300 participants for the 3 studies I'm going to prepare to show. For each studies, we had 3 different stages. First, the participants filled in the pre-questionnaires. We used NARS to find out the a priori attitude of participants towards the agent. So we adapted the NARS, which is made for robot to virtual agent. Then the participants interacted with the agent. And after we had post-questionnaires, where we asked participants several questions regarding the perception of the agent and also the perception of the interaction quality. So the first adaptation here that we considered is nonverbal behaviors. Okay, so the goal is that the agent learn the best combination of nonverbal communicative behaviors according to his own goals to be perceived as either warmth or socially competent. Warmth and competence are 2 important dimensions in social interaction. Okay. For this work, we relied also on work by Cheng Wang from University of Geneva that detect the user's impression of the agent's warmth and competence from its multimodal behaviors, in particular facial expression. For the learning part, we use reinforcement learning, where the action is the verbal and nonverbal behaviors that the agent should display next, and the reward function is a detected impression. So you can see here that the adaptation mechanisms is between the dialogue models that compute the next communicative intention to be conveyed by the agent and the agent behavior. That means that given an intention, the adaptation mechanisms find the best type of nonverbal behaviors that could be used to convey this intention. And we consider different type of gestures. It could be didactic, iconic, performative gestures, beat gestures, as well as different type of arm rest position, the kimbo or on the like that, arm cross or along the body and things like that. But we also consider smiles and different verbal attention. For the dialogue models, we relied on Philippe, which is dialogue model developed at University of Twente. So participants connected, and we found some interesting results that at the end of the interaction, the model did learn what will be the best type of nonverbal behaviors that will fit a user's preference of having and to interact with an agent being appearing more warm or competent. The second study works at other levels of adaptation. Here, we're looking at adapting the agent's conversational strategies. That means that the models want to learn the best combination of conversational strategies according to its goal to engage the users. And we consider different conversational strategies linked to warmth and competence. We considered ingratiation, supplication, intimidation, and self-promotion. And each of them, two is linked to warmth and two are linked to being socially competent. As you can see here, the adaptation mechanisms comes before the dialogue manager. So it's between the user's analysis, so detecting how engaged the user is, as well as the dialogue models. Okay. So when the agent, as the model detect the level of engagement of the users, this information is sent to the adaptation mechanisms that compute with the dialogue models what to say next and which conversational strategies. And these conversational strategies are implemented verbally through the different set of use of different type of pronouns. It could be you or we words, the level of formality, the length of the sentence, that means the quantity of details you can provide, the agent will provide, as well as the non-verbal behaviors that are associated for portraying warmth and competence. And here, the reward function was users' engagement. Okay, so here you can see really that it's conversational strategies. Well, the one before was associating the more fit, the better fit non-verbal behaviors. The third study is something else. Here is really at a much lower level, which is looking at how to find out an adaptive loop between users' analysis behaviors and the agent's behaviors. It's a bit like we've done for the laughter, except here it's using a machine learning approach, while before it was done on the fly and there was no learning at all. So in this work, we wanted to develop computational models that capture the adaptation of the interaction as a cues level. And we want to predict the agent behavior taking into account the user's cues levels, while the agent, of course, should convey the communicative intents. So the adaptation mechanisms is based on LSTM models, and it takes as input the user's analysis and output the behavior, agent behaviors. The learning of the models was done on human-human interaction, and we realized on the NOXI database that we have collected earlier on. So the models learn how the two human interactant, the dynamic loop of the behaviors of the two human interactant. And we use only upper body, in head movement and gaze direction and facial expression, smile, because since it's talking a lot, we didn't want to have other type of facial expression. So we use smile. And after, when we've added the adaptation mechanisms, it's frame by frame, the models detect the user's behaviors and predict what the agent should do frame by frame. Of course, it uses time windows, the sliding time windows for such a computation. So to conclude this talk, I went very fast. I presented several works where we had different forms of adaptation mechanisms linked at the body movement, behaviors, strategies, cues. And those type of adaptation mechanisms does enhance the quality, the perceived quality of the interaction, as well as the perception of the agent, in particular in terms of warmth and competence. But of course, we need to do much more work, and particular to models complex phenomena such as rapport buildings or empathy or emotion, things like that, something we didn't consider at all. And also, we need to enhance our objective and subjective measures for evaluation. That's finished my talk. So if you have any question, I'll be very happy to answer.